All right, so welcome back. Let's talk about 11.6 properties of chords. So yesterday we talked about inscribed angles and polygons. Today we're going to talk about properties of chords. So again, if we remember back from properties of a chord is just a segment within a circle, and it goes from one side to the other, but does not go through that center. Okay. All right, so let's talk about theorem 11.10. All right, so if two chords intersect inside a circle, then the measure of each angle formed is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. I know that was a lot of words, but don't worry, we'll get to what that means. So, in the picture that I have to the right here, let's say I want to find the measure of angle 1. So angle 1 is this angle that is right here. Okay, let's say I want to find that. Well, in order to find that, I have 1/2 the measure of, I'm going to do this in orange, AB, which is this orange arc, plus the measure of CD, which is that other orange arc. Again, arcs and angles are very different. Arcs are on the circle, angles are inside of my circle. Okay. All right, let's talk about finding the measure of angle 2. So angle 2 is this other angle that is here. I'm going to find the measure of angle 2. So in order to find the measure of angle 2, if I'm given the lengths of my arcs, I can have 1/2 times the measure of AD, so that green arc that I'm coloring in now, plus the measure of BC, this other green arc. Notice that my green arcs are opposite of each other, right? They don't touch. And also my orange arcs are opposite of each other. They do not touch as well. Okay, let's use this theorem and put some work to it, put some math to it. Okay, so let's talk about example 1. So I want to find the value of x. Well, first I have to determine, do I have an arc or do I have an angle? Or what am I trying to find? An arc or an angle? In this case, my x is this part here. That is inside my circle, so that is an angle. Okay, so using the theorem from above, I'm going to find that angle using the two arcs that are across from it. So if I look at x, my arc that is across from it is this one here, this green arc here. The one that is directly opposite of that green arc, that does not touch it, is this arc here. Okay, I cannot say that it is this arc here, because that means that those two green parts are touching. Well, I don't want them to touch, so it's going to be these two because those ones do not touch. Okay, so let's fill in. So using my theorem 11.10, x equals 1/2 the measure of RQ plus the measure of PS. Again, arcs have that little arc over those two letters. Well, let's substitute. So the value of x equals 1/2. Let's replace QR. QR I know to be is 174. Plus the measure of PS. PS is 106. I can add those two together. So let's add them up. I still have my 1/2. I didn't touch that yet. But when I add what's inside my parentheses, so the 174 and the 106, I should get 280. 1/2 times 280, or 280 divided by 2, is 140. And x equals 140. Let's go down to example 2. So example 2, again, I want to solve for the value of x. Again, I have to determine, am I given an arc or am I given an angle? And what am I trying to find, the arc or the angle? So in order to find what I'm looking for, I need to find where my variable is. So in this case, my variable, x, is right here. So is that an arc? Is that an angle? In this case, that is an arc. Okay, so let's label which arcs that I have to talk about. So I labeled my x, so that one I need. Which one is directly across? Would it be this one here? It shouldn't be, because those two green parts would be touching, and that's not what I want. Could it be this one? It could not be, again, because those two green arcs are touching. So it has to be this other arc that is there. So let's fill in some stuff that I know. So the measure of AEB is this angle here. That's what I'm given. Equals 1/2 the measure of AB plus the measure of CD. Again, my arcs have that little arc on top. Let's substitute what we know. So AEB is 80 degrees, equals 1/2 the measure of AB is X, plus the measure of CD. CD is 60. Again, I can look right back at my picture, X and 60. Okay, then it says use my distributive property because I want to solve for X. Distributive property says take that 1/2 and multiply it to everything inside my parentheses. So my 80 I didn't touch. 1/2 times X is just 1/2 X. 1/2 times 60 is 30, and that gave it to me, so I am done there. Well, in order to get X by itself, I still have to do some math. So in order to get X by itself, I'm going to subtract that 30 over on both sides. So 80 minus 30 gives me 50, equals 1/2 X. Okay, well, I still need to get my X by itself. Right now I have a 1/2 attached to it. In order for me to get rid of a fraction, I'm going to multiply by the reciprocal. So the reciprocal is just the flip of that fraction. So right now I have 1/2. So the reciprocal of 1/2 is 2 over 1, or 2. So I'm going to multiply each side by 2. So this times 2 just gives me X by itself. 50 times 2 gives me 100, and I solve for my X. X should be 100. Let's move down to checkpoint. So I'm going to do the first one with everyone, and then it would be a good suggestion to pause after the first one, try the 2 and 3 on your own, and then play when you are ready. So number 1. So again, I have to find, am I given an angle or an arc, and then what am I trying to find? So I'm going to rewrite that formula that we have. So it's my angle equals 1/2 arc plus arc. So right now, if I look at number 1, I'm trying to find where X is. So X is right here. Well, is that an angle or is that an arc? In this case, it's an angle because it is inside my circle. Arcs are typically outside if I look at the difference, okay? So the arc that relates to that X is this one here, this green one that I'm highlighting. The one that's directly across is going to be that 70. Again, it can't be this one because then those two touch. It can't be this one. Those two would touch. All right, so my angle right now is X. We're going to replace using this formula. Equals 1/2. One of my arcs is 190. The other one is 70. Add what's in my parentheses first, so those two, add them together. Multiply by 1/2, X should equal 130. Again, this is a good point to pause the video, try the next two on your own, and then play when you are ready. So the next one, again, I want to find, determine what I'm given and what I need to find. So in this case, my X is here, that's inside my circle, so that has to be my angle. The arc that relates to that is this one here. The one that's opposite is this one. So my angle is X equals 1/2. One of my arcs is 66. The other arc is 70. Add my 66 and 70 together, times by 1/2. X should equal 68 degrees. And then our last one. In this case, my X is here. Well, notice that my X is outside of my circle, meaning that it is an arc, not an angle. So in that case, I need the opposite arc. So the opposite arc is this one here. The angle that I'm given is 72, so let's plug in stuff that I know. So my angle, using that formula again, my angle goes first, so 72 equals 1/2. One of my arcs is X. The other one is 99. Okay, so I could take a couple routes. I could use the distributive property, but I find that having a 1/2 in there, I'd rather just get rid of it right away. So in order to get rid of that 1/2, I'm going to multiply by the reciprocal. The reciprocal is just 2, so multiply by 2 on both sides to get rid of those 2. I'm left with 144 equals X plus 99. Again, I don't have X by itself. I need to solve for X. Move over that 99 by subtracting it, so I have 144 minus 99, I get x to be 45. All right, our next theorem, theorem 11.11. So if two chords intersect inside a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the other chord. Again, I know that's a whole bunch of words. We're going to talk about what that really means. So, in shorter terms, this means that EA times EB equals EC times ED. And I'm going to highlight what I'm talking about. So AE is this part here times EB. Notice that the green and the pink combine together to form a chord or one straight line. Okay. And then I have EC, which is this one here, times ED. Again, if I look at my orange and my blue, they form one straight line. They are a chord. If I were to pick something like the green and the orange, well, the green and the orange do not create a chord, right? It's not one straight line. So those, I would never multiply those two together. Okay, so it's always the opposite one, or the ones that create a straight line. Again, that was a whole bunch of words. Let's put some math to it. It'll make a little bit more sense. So let's move down to example 3. So I want to find the value of x. So notice that ST and QP are chords that intersect at R. So I have two chords. That's one of my things that I need. I need two chords within my circle, and they have to intersect. So ST and QP are chords, and they do intersect at R. Okay, so let's fill in some stuff. So RS, again, I'm going to highlight as we go. So RS is that one there, times RT, which is that one there. Well, again, if you look again at my pink and my green, if I look at them, they form one straight line. That's my chord. And then I'm just going to label this other one here and this one there. So my orange is QR times RP. In my cases, I'm going to do my pink and my green on one side and then my orange and my blue on the other. You do whatever colors you want or don't use colors at all. Colors typically make more sense to me, and I think it's pretty helpful, so that's why I do this way. Okay, so let's fill in what I know. So RS, if I look at my picture, RS is that pink segment, and that is 3, times my green segment, which is 6, QR, which is in the orange, is 9, times my blue, which is X. Okay, let's solve for X. So in order to do that, let's start with the left side first. You can start with the left or the right. I'm just going to start with the left just because. 3 times 6 gives me 18. 9 times X gives me 9X. Okay, I still don't have X by itself. In order to get X by itself, I'm going to divide by 9 on both sides. X is left alone here. 18 divided by 9 gives me 2. So X equals 2. Hopefully that made a little bit more sense with the colors and what they mean and what that definition means. Let's move down to the last portion of this notes. So again, I'm going to do my pink and my green across from each other. So if I look at my pink and my green, they form one line. Again, I'm just picking. It doesn't have to go this way. My orange and my blue are going to be across from each other as well, just because that's how I am doing it in my video, in my notes. You can do it with any other colors that you want or labels. It's totally up to you. Okay, so again, if I notice my pink and my green are across from each other, they form one straight line. My orange and my blue form one straight line as well. So let's do my pink. So my pink is NP times my green, PL, equals my orange, PM, times my blue, PK. So what I'm going to do is solve for X. Again, we need that property. Do I have two chords in my circle, and do they intersect? In this case, I do have two chords, and they do intersect. Okay, so let's plug in what I know. In my pink, NP, I have 12 times my green, 6, equals my orange, which is 12, times my blue, which is X. This is my blue. This is my orange. This is my green. And lastly, this is my pink. Okay, so let's start with the left side first. Again, just because you can start with the left or the right, doesn't really matter. In this case, 12 times 6 gives me 72, equals 12 times x, which is 12x. In order to get x by itself, I'm going to divide by 12. I get x to be 6. Okay, again, this is a good point in the video to pause the video, try the next two on your own, and then play when you are ready. All right, so I'm going to continue. So I'm going to start just coloring in some stuff. Again, I'm doing my green and my pink across from each other, and then my orange and my blue across from each other. Let's put some labels to these. So my pink is AB times my green, BC, equals my orange, BE, times my blue, BD. And my last one. All right, so again, I am going to just replace what I know. So in my pink, I know that's 6. In my green, that is 6, equals my orange, which is 9, my blue, which is X. On the left side, 6 times 6 gives me 36. On the right side, 9 times X gives me 9X. Divide by 9, so 36 divided by 9 gives me 4 as my X. And our last one, so again, I'm just going to label, color in some stuff. Again, I'm doing my green and my pink across from each other, and then my orange and my blue across from each other. So I have Rx times V, sorry, that was wrong. RV, there we go, times VT equals UV times VS. Here's my blue, here's my orange, here's my green, and then here is my pink. I'm going to pick it up just a little bit because I'm just going to replace some stuff that I know. So my pink is 6, my green is 4, equals my orange is 8 times my blue, which is X. On the left side, I get 24. On the right side, I get 8X. Divide by 8, I get X to be 3. Okay, so in this unit, we talked about properties of a chord. We talked about multiplying chords inside of a circle and if they intersect. We also talked about finding angles and arcs based on angles and arcs that I am given. Okay, so that was 11.6, properties of chords.